Hello there. So we have our last lesson in Chapter P today, which means you guys have a test coming up here pretty soon. But this lesson is one in which you guys already have some familiarity for, and which is a good thing to go out on. And we're going to be talking about really the coordinate plane today, the coordinate system, but even more so some formulas that go along with it, namely the distance formula and the midpoint formula. Okay, two formulas that you should, again, be familiar with. We're going to practice with them a little bit more. And so let's start with the distance formula, okay? So the distance formula, if you can think back to your Algebra 1 class, the distance formula, think about what it does. If you have 2 points in the coordinate plane, so if I just put 2 points anywhere, okay, here and here, the distance formula will calculate the distance between those 2 points. Really, it calculates the length of a segment that connects 2 points. That's what it does. And so the way it works, we take d equals, distance equals, square root of, so a big square root, of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And that's the distance formula. And so in doing this formula, that'll calculate the distance between 2 points. So example 1 says, find the distance between -5, -2, and 1, -5. Expressed in simplest radical form. When you see simplest radical form, what that means is, because if you notice there's a square root in the distance formula, what that means is you're not going to be taking the square root of your number at the end if it's not a perfect square. So if you get square root of 5, you just leave it as square root of 5. If you get square root of 20, then you have to simplify the square root of 20. That's what it means, simplest radical form. So what we're going to do is d equals square root of. So the whole x2, x1 doesn't mean like x squared or y squared. All it means is you have 2 different x values, subtract them. That's all that means. And it doesn't matter the order in which you subtract them. It doesn't matter the order. Some people say, well, you always have to do the second one minus the first one. Well, no, because when you square, you're going to get a positive in the end anyway. Like if you would do 3 minus 2 squared versus 2 minus 3 squared, you end up at positive 1 either way. So you just have to take your 2 values and subtract them. Now my advice, the way I do it, I always pick the order that's going to give me a positive. So for this first one, when I subtract the x values, I'm going to do 1 minus -5. 1 minus -5 squared. And for the other one, I'm going to do -2 minus -5. So I'm going to flip the order of the y's. And then some people always think, well, don't you have to do it in the same order? Not with these. And what that is for the slope formula. When you're doing y2 minus y1 over x2 minus x1, you have to do them in the same order. But for this, the order doesn't matter. So we're going to have -2 minus -5 squared. And now we just go to work. So we have 1 minus -5, that's 6. 6 squared is 36. Plus -2 minus -5 is 3. 3 squared is 9. When you get here, you can't just take the square root and square root each term separately. We've talked about that a little bit in this course. A square root sign is like a grouping symbol. It's kind of like parentheses. You have to simplify under it first. So when you simplify this, you're going to get the square root of 45. Now, simplest radical form means we need to simplify the square root of 45. So however you guys do that, but I'm going to go ahead and do a factor tree. So 9 and 5, 3 and 3. Pair of 3's. So this is 3 square root of 5. And understand what that means. That means if I would plot these 2 points on the coordinate plane and connect them, the length of that segment would be 3 times square root of 5. So 7 point something probably. I'm not sure, but it says keep it in simplest radical form. Okay. Next, I want to talk about the midpoint formula. So the midpoint formula is if you have 2 points in the coordinate plane and you connect them, the midpoint formula finds the point directly in the middle of that segment. So the midpoint formula finds the midpoint of a segment. So distance formula finds the distance between them, midpoint formula finds the midpoint. So the midpoint formula is this. You're going to add your x-coordinates, divide by 2. That finds you the x-coordinate of the midpoint. Comma, do the same thing with the y's. y1 plus y2 over 2. And what this is doing, this is taking the average of your x values and then the average of the y values. That's what this midpoint formula is doing. So it's finding the point right in the middle of your x's and the value right in the middle of your y's. So let's jump down to number 4 here. We'll go back to 2 and 3. Let's jump to 4. It says find the midpoint of the segment joining these 2 points. Okay, so midpoint. I'm going to do -5 plus 9, add your x's, divide by 2, comma, -3 plus 3, divide by 2. So here you can get +4 on top divided by 2, so that's 2. And then you get 0 on top divided by 2, that's 0. And you can kind of check this pretty quickly. Think about just the x value. 2, think about how it relates to -5 and 9. 2 is 7 units away from -5, and 2 is 7 units away from 9. So 2 is directly in the middle of -5 and 9. 0 is smack dab in the middle of -3 and 3. 0 is 3 units away from -3 and 3. It's right in the middle. And so that's what we just found, the midpoint. All right. So let's just do a little more practice here. Example 2. Find the distance between 1/2, comma 4, 2/3, comma -1/2. So we're just going to use the distance formula, but now we just have some fractions to deal with. And that's fine. I mean, fractions are no big deal. So we have d equals square root of. We're going to do x2 minus x1 squared. So I always like to do the biggest minus the smallest to get a positive value. So I'm going to do 2/3 minus 1/2 squared. Plus, now I'm going to do the y's. 4 minus -1/2. 4 minus -1/2 is 4 plus 1/2 squared. Now we just have to deal with some fraction work, which is fine. We can't be scared off by fractions. So 2/3 minus 1/2, we have to get common denominators. So 2/3 would be 4/6. 1/2 would be 3/6. So 4/6 minus 3/6 is 1/6. Plus, so I'll say this, 4 plus 1/2, a lot of students would say, well, that's 4.5. And it is 4.5. But in algebra, especially, you don't really ever want to work with mixed numbers. So we always like to turn mixed numbers into improper fractions. So 4.5 is really 9/2. So that's where we're at now. And so now we just need to square each of these. Let's square. So we have 1/6 squared. Well, we just square the top and bottom. So you have 1 over 36 plus 81 over 4. So we're getting somewhere. And now we need to add these two things together. So we need common denominators. We can turn 4 into 36. Let's multiply this by 9 over 9. Okay, so we have 1 over 36 plus, well, this is going to be 729 over 36. Now we can add them, and we get square root of 730 over 36. When you have the square root of a fraction, you can actually take the square root of the top and the bottom separately. So I'm going to do that. I'm going to put the square root on top, so square root of 730. And on bottom, the square root of 36 is just 6. Now, I boxed that off because I know what the answer is here, but what I should try to do is off to the side, do a factor, try to simplify the square root of 30. So I shouldn't have boxed this yet. I just know that that doesn't simplify. But off to the side, we should say, okay, let's simplify the square root of 730. So we get 73 and 10. 73 is prime, so 2 and 5. And then since you don't end up with any pairs, it just stays the square root of 730. And you can't reduce this, you can't do anything with this, you can't simplify a radical and a non-radical. So that's your answer right there. You're done. So distance formula just with some fractions to work with. All right. Example 3 says verify. Now this word is interesting. Verify. Think about what the word verify means. Verify means prove or justify or show. And so anytime a question says verify or prove or justify or show, Whatever is about to come next is a true statement. Let me say this again. It says verify. So whatever is about to come next is true. We need to prove that it's true. So think back to your proofs in geometry, and I know a lot of you love them. I'm not going to have you do 2-column proofs. You're not going to have to set up statements and reasons and, side angle side and vertical angles theorem. We don't have to do that. But we do need to show mathematically that these 3 ordered pairs, if you would graph them, that these 3 ordered pairs form a right triangle. Okay? Now you can't just plot them and then draw the triangle and be like, look, there's a right angle there. It looks like a right angle. You can't just say, look, it looks like it is. We need to show mathematically that these form a right triangle, okay? And so now you need to think about, what do I have to do to prove something forms a right triangle? Anytime you're dealing with right triangle, hopefully Pythagorean theorem comes into your mind. So to prove that these 3 ordered pairs form a right triangle, we need to show, here's what we actually need to do. We have to show that the Pythagorean theorem holds true. We need to show that a squared plus b squared equals c squared. That when we find the side lengths satisfy the Pythagorean theorem. And that proves that it forms a right triangle. So we're getting into some geometry here. Okay, so first and foremost, we have to show or find the side lengths. Let's label these points A, B, and C, just so when we're naming them, we can actually talk about them with letters. So we have points A, B, and C here. I want to find the length of all 3 sides of this triangle. Well, that's what the distance formula does. The distance formula finds lengths of sides, of segments. So let's first find the length of AB. So I'm going to do the distance formula between A and B. And I'm okay if you guys do a little shortcut, in here. You don't need to show every little step. And here's what I mean by that. I know I'm going to subtract the x's and square it. 4 minus 2 is 2. 2 squared is 4. Plus, I know I'm going to subtract the y's and square it. So 1 minus 0 is 1. 1 squared is 1. And so you get the square root of 5. So I don't have to see every little step. I need to see something along the way, but not every tiny little thing. Okay, let's find BC. So now I'm going to do the distance formula between B and C. So 5 minus 4 is 1. 1 squared is 1. Plus 7 minus 0 squared is 49. So we get the square root of 50. And then I want to find AC, side length AC. So 5 minus 2 is 3. 3 squared is 9. So I'm subtracting the x's and squaring it. That's what I'm doing there. Plus, let's subtract the y's and square it. 7 minus 1 is 6. 6 squared is 36. So we get the square root of 45. Okay. So in the Pythagorean theorem, a squared plus b squared equals c squared. It's important to know what's a, what's b, and what's c. C is always your longest side. Whatever the longest side is your c. So if I'm looking at these 3 sides over here, it doesn't just go alphabetical. It doesn't go, well, here's A, here's B, here's C. The longest side length is the square root of 50. Here's your C. The A and B are interchangeable. It doesn't matter which one's A or B. So what we need to show now is that A squared plus B squared is in fact C squared. Now think about what would happen if we're about to go and do the Pythagorean theorem and it doesn't work. It doesn't work. Think about what that means. The problem said verify, or prove, or show, or justify. This is telling you it is true. It is true. So if you go through your process and you're trying to verify something and it's not true, you did something wrong. Understand that. You don't say, no, it's not true. They're telling you it is. Your math has to back it up. Okay? So now we're going to do a squared plus b squared equals c squared. So square root of 5 squared plus square root of 45 squared equals square root of 50 squared. Let's make sure this is true. Well, square root of 5 squared is 5. Square root of 45 squared is 45. Square root of 50 squared is 50. 50 does equal 50. Woo! Now, that's not, you don't just move on. You don't, drop your pen and move on to the next problem. You have to write a little statement just showing what you just found. Like, explain your work. Why is what you did enough to verify this? And so here's a little statement you can make here. Since a squared plus b squared does equal c squared, because that's what we just showed, since a squared plus b squared does equal c squared, the vertices form a right triangle. So you do need to write a little statement just backing up what you found. That way you can't just do a whole lot of math and something works out and you move on. You need to actually explain what your math just did. And that's essentially doing a proof right there, just without the two columns. All right. Example 5. A segment has one endpoint at -1, 5 and midpoint at 4, -2. What are the coordinates of the other endpoint? So understand the difference between example 4 and example 5. Example 4 was finding the midpoint. That's what the midpoint formula does. It finds the midpoint for you. Example 5 is not asking you to find the midpoint. They're giving it to you. And here's the other endpoint. They want the other endpoint. Now, you can use the midpoint formula in a way to do this, but I kind of like to do this. I like to think through this a little bit. Okay? Think about what midpoint means. Just think about this. This x value right here, this 4, has to be somewhere exactly in the middle between -1 and some other x value, the other endpoint. So think about how far apart -1 and 4 are from one another. If I'm at -1, think about how many units it takes to go up to 4. Well, I have to go up 5 units, which means the other endpoint must be 5 units away from 4. So think about what number is also 5 units away from 4 on the other side. Like if I went up 5 again, think about where you'd be. You'd be at 9. So 4 is right in the middle of -1 and 9. It's 5 units away from both. You can do the same thing with the y's. -2 has to be somewhere right smack dab in the middle between 5 and some other y value. So think about how far apart they are. Well, these are 7 units apart. It's from 5 to get to -2. From the endpoint to get to the midpoint, you have to go down 7 units. So if I go down 7 more units from -2, -2 minus 7 is -9. -2 is smack dab in the middle of 5 and -9. It's 7 units away from both. Like I said, there is an algebraic way to go about that. If you want to see that next class, please ask. Or think through it if that doesn't make sense. But you'll see this on the homework, and then hopefully if you do have a question on it, we can talk through it a little bit more in class. Okay? So there's your distance and midpoint formulas. All right? The last thing we're going to talk about is the equation of a circle. All right? You guys have dealt with lines for quite some time now. And if I said, what's the equation of a line? Hopefully you'd be like, oh, y equals mx plus b. Right? You know the equation of a line. But a circle also has an equation. And maybe you've seen it in geometry. I hope you guys have talked about the equation of a circle in geometry. Maybe not. But here's the equation of a circle. I'm going to write the equation and then tell you what all the variables stand for. So your circle equation is this. It's x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. This is your circle equation. This is the standard form of a circle right here. Now, formulas and equations mean absolutely nothing unless you know what the variables stand for. So think about what's important in a circle. There are 2 very, very important things when you're talking about a circle. Think about what those 2 things are. And those 2 things are the center of the circle. The center is probably the most crucial point on a circle. And that's what h and k stand for. So off to the side, I would probably write the center is the ordered pair h comma k. H comma k in this equation is the center of the circle. Notice real quick that the signs do technically flip here. If it's x minus h, then the x coordinate of the center is positive h. And it's y minus k, and the y coordinate of the center is positive k. So whatever that sign is in here, when you actually name the center, the sign flips. The other important thing of a circle is the radius of the circle, because the radius stays the same throughout a circle. That's what r stands for. R is the radius. All right, so let's go ahead and think about how we can use this. So 6 says find the center and the radius of this circle. Okay, here's a circle right here, because it's in that form that we just talked about right here. So let's first find the center. The coordinates of the center. Well, it says x plus 5 squared. And remember, whatever this value is, the x coordinate is going to flip when you name the center. So if it's positive 5, it's going to be negative 5, comma. If it's y minus 2, then the y coordinate is positive 2. So the center of the circle is negative 5, 2. The radius of this circle, well, look over here. In the formula, it's r squared, but radius is r. So this 9 right here is technically r squared. So think about what the radius would be. It'd be 3. The question doesn't say to graph it, but I do want to show you guys what it means if we could take this information and graph this circle. Okay, I'm going to plot the center at negative 5, 2. Here's the center. From the center, we're going to go 3 in all directions, which means we're going to go left 3, up 3, right 3, down 3, and plot points. Okay, so from the center, let's go up 3. We're just drawing a rough sketch. 1, 2, 3. Let's go right 3. Let's go left 3. And down 3. And here is really the outline of your circle, and now you can graph it. It's just a rough sketch. But this is what that equation stands for, right there. Also, one important thing to note, and when we get into graphs of equations, this will come up also, but in every single equation of anything in the world, okay, anything in the world, not for circles or lines, but for anything, x and y stand for ordered pairs that are on the actual circle. X and y always stand for points on your graph. Whatever that graph is, x and y stand for all the points that are on that graph. That's what any equation is in the world. So h comma k is the center, r is the radius, and x and y stand for points on the actual circle. Okay? All right, 2 left. Now we're going to go in the other direction. It says write the standard form of the equation of the circle. Now they're giving us the center, so they're giving us h and k. And it says a solution point is negative 1, 1. What a solution point is, that's what I was just talking about. A solution point is a point on the circle. So really, they're giving you an x and a y right here. They're giving you x and y. Okay? So we know h, k, x, and y. I want you to think about, in order to write the equation of a circle, okay? I want you to look back at the previous example really quick. In order to write the equation of a circle, look at what 2 things you have to know to write the equation. You have to know the center, so the h and the k, and you have to know r to get r squared. Those are the things you need to know, okay? Well, in this problem, we know the center. We already know half of what we need. We don't know the radius. Somehow we have to find the radius. And there's multiple ways to find it, but one way is, look at the circle equation. It's x minus h squared plus y minus k squared equals r squared. Here's the circle equation. Look at all the information we know. We know h, we know k, we know x, we know y. We could plug these 4 numbers into this equation and figure what r is. That's the only thing we don't know, but we could find it from the information they give. Take these values and plug them in. So let's do that. Just be careful where you're plugging stuff. So x is negative 1. It's minus h, so be careful here. H is 3, so it's minus 3 squared plus plug 1 in for y, and then minus k, so minus negative 2, so plus 2 squared equals r squared. We're trying to find r. Well, now we can just clean this up and find r. So here we're going to have negative 4 squared, so that's going to be 16, plus 3 squared, which is 9, equals r squared, which means r squared is 25. which means r is 5 when you square root both sides. Now we can write the equation. An important thing to note, when you write the equation of anything, x and y stay in the equation. You don't replace x and y. We need to replace h, k, and r, or r squared. Okay, so we know it's going to be x minus 3 squared plus y plus 2 squared equals 5 squared. Here's the equation. Notice h was 3, positive 3, but it's x minus 3. K was negative 2, so it's y plus 2 in the parentheses, and then r squared is 25. And there's our equation. Right there. All right, last one. Write the standard form of the equation of the circle with endpoints of a diameter at 0, 0, and 6, 8. All right, so they're giving us some different information here. They're not telling us the center. They're not telling us the radius. And those are the two things we need to write the equation of a circle. We need to know the center and the radius. We don't know either. But obviously they give us enough information to figure it out, or we couldn't do this problem, right? We got to figure out how can we use the information. So there's multiple ways to go through this problem. But if we're looking for the center, think about what a diameter is. I'm gonna sketch this real quick. Okay. Here's the center. I don't know exactly where these points are, but I'm just going to label this. Think about what a diameter is, okay? Diameter goes through the center of the circle. So let's pretend like this was 0, 0, and this was 6, 8. How could we use that information to find the center of the circle? What in the world have we learned that would find the ordered pair for the center? We're looking for a point right in the middle of these 2 points. Well, that's where the midpoint formula comes into play. So the center of this circle is the midpoint of the diameter endpoints, right? So we're going to find the midpoint between these. So the midpoint formula, we're going to add the x's, divide by 2, comma, add the y's, divide by 2. So we get 3, comma, 4. That is the center of the circle. We said we need 2 things to write the equation. We need the center and we need the radius. We found the center. Now you have a couple options of finding the radius. You could use the distance formula, right? Because we know this is 3, comma, 4. You could use the distance formula and find this distance right here, because that would tell you r, right? If you did the distance formula between these 2 points or these 2 points, that would find you r. That's option 1. Or you could do what we did on the previous problem. Because now we know h and k. These right here are points on the circle. Pick either pair and plug those in for x and y. And then do what we did up here and find r squared. So we can do that if we want. So that's up to you which method you would want to use. Since up here we plugged in h, k, x, and y, I guess for this one I'll do the other way. I'll find the radius using the distance formula. So the radius is going to be the distance between 3, 4 and 0, 0. Or 3, 4, and 6, 8, either way. I'll do 0, 0 because that'll be easier math to work with. So I'm going to do x2 minus x1 squared. So 3 minus 0 squared is 9. 4 minus 0 squared is 16. And so you get the square root of 25. So the radius is 5. Well, now we can write the equation of this circle. It's going to be x minus 3, because that was h, squared, plus y minus 4 squared equals r squared, so 25. So what you need to understand, and I've mentioned this in the classes before, you're going to learn different ways to go through problems, okay? And what you need to understand is when you go through math, you are just gathering tools to put into your toolbox. The distance formula is a tool. The midpoint formula is a tool. You have tools, and now you have to figure out how can I use them? When can I use them? What do they do? And so right here, the problem didn't say, well, on this one, we're going to use the distance formula and the midpoint formula. It didn't say that. But you have those in your back pocket in order to find information that you need. It's kind of like a puzzle. You're looking for a missing piece of the puzzle. You need to ask yourself, what have I ever learned that can find that missing piece? And that's what math is, okay? So go ahead and work on the assignment. If you have any questions, don't hesitate to shoot me a Canvas message or email me. We'll work through these. And then we'll have a review day next time, and then test the class after that. Peace.